Hello, in our last lesson, we have learned the power rule. So if f at x equals a times x to the exponent n, then the slope of tangent at a random x value we call f prime of x is 2 steps. So bring the n to the front, then a times n, then the exponent, second one is exponent minus 1. So there are 2 steps. First one, bring the n to the front. Second step, degree minus 1. So there are 2 steps. Then after that, you have the derivative of the function f of x. And this is the slope of tangent. And in this lesson, we are going to develop a rule for other functions, like the multiplication of 2 functions, such as 2x squared minus 1 times bracket 3x cubed plus x minus 8. Each of them we could treat it as a polynomial functions, like a times x to the exponent n, but together we don't want to expand it and do it. We are going to see the rule that we could use to do the derivative of this product of 2 functions. So this is a rule for it. If k at x equals f at x times g at x, then the derivative is first function derivative times second function, then plus first function times second function derivative. So f prime times g, f times g prime. And in Leibniz notation, we use d over dx, u times v, then first function derivative times second function plus first function times the second function's derivative. Okay, and we want to see why it works. We call it a proof. So for the proof, we are going to use a first principles method. So we are going to start from the definition of the derivative is a slope of tangent. So proof k at x equals f at x times g at x. Then the derivative of k at x is k prime of x equals the limit when h approaches 0, k bracket x plus h minus k bracket x over x plus h minus x give you h. So this is a delta y over delta x. So this is the slope of the tangent. Then we are going to sub in f at x, g at x, and see how we could get to f prime g plus fg prime. So k at x plus h, we sub in x plus h here. It will change f at x plus h, g at x plus h. Then minus kx, just f at x times g at x, all over h. And compared to f prime, it's far away. We want to make f prime x out. And we know that f prime x equals, so we know f prime x equals limiting value when h approaches 0 is f x plus h minus f at x over h. So compare this one. We have x plus f at x plus h here, but we don't have minus f at x. So we are going to make it up. So minus f at x. Then I don't want to change the expression. So minus f at x plus f at x, it will give you 0. So we are going to change the f x plus h to f at x plus h minus f at x plus f at x, then times g at x plus h. So we are going to rewrite it. Limiting value when h approaches 0, we have f x plus h. We are going to just keep the f minus f of x here. Then we times g x plus h. And don't forget we have plus f of x here, so we are going to plus f of x, then g x plus h. So you will see three terms we separated. First two terms times g at x plus h, then plus f at x times g at x plus h. Then the last term we just copied here, minus f at x, g at x. Then all over h. Then you will see the first term. Limiting value x h approaches 0, we are going to just copy this here. We separate the two limit from the plus sign. So this is our first limiting value, then plus the second limiting value. The second one is here, so it's the last part. This one we are going to put it here, and we have f at x. They are common factors. This is multiplication. If we have common factor, we could take the common factor out, so f at x, then each term divided by f at x, we have g x plus h. Then this one is minus g x. And you will see that this part is our definition for f prime x. So we could write it as f prime of x. Then here we sub in h equals 0. So this one g at x plus 0. Then the second one, the limiting value of that part. So limiting value of this part is our definition of g prime. So f at x, no h, is just f at x. Then the limiting value is g prime x. So this one x plus 0 is g at x. So if we write it again, is what we have. K prime of x equals f prime x gx plus f at x g prime x. And this is a way that the mathematician figured out the product of two functions. The derivative equals first function derivative times second function itself, then plus first function itself times derivative of the second function. And this is the rule that we learned today. So you need to memorize this product rule. Then after that, we are going to apply this rule to see how we can find the derivative of a function which is a product of two functions. So now we are going to see we have a differentiate. It means you are looking for the derivative of function, this function f prime. So f prime of x equals, this time we have these two functions multiplication. So using the product rule means first function derivative plus first function and times a second function derivative. Okay, so we are going to follow this product rule. So x squared minus x, the derivative, we are going to have x squared, bring the, so separate as two terms for the power rule. So the power rule is our first derivative rule. So this one prime is the constant at front, n bring to the front, and n minus 1. So x to exponent 2, n is 2. We bring the 2 to the front and 2 minus 1. So x exponent 2 minus 1 is 1. Then minus x, bring the 1 to the front, then degree 1 minus 1 is 0. Anything to the exponent 0 is 1. I will just write it as this form. Later I will simplify it, but if you could see it, you give me 2x minus 1 right away, it's correct. Then the second function, we just copy it down. So the first term, just do the derivative for the first function. Then the second function, first function, we just copy it down. Then we just do the derivative to the second function. So 2x cubed, constant at front, bring the 3 to the front, then the degree minus 1. 3 minus 1 is 2. Then minus 1. Minus 1 is constant, x to exponent 0, so it's 1 times 0 is 0. Then we simplify, so this is copy this one down, then x squared minus x. This one 2 times 3 is 6x squared. If the question didn't ask you to simplify, this is your final answer. You don't have to go over. Okay? This is example 1. Then we continue to see example 2. So just need to practice. So example 2, find the value g prime at -1. So in order to find the derivative of function g at x equals -1, we want to find the g prime at x, any x value. Once we have this g prime of x, we could substitute x equals -1 to find the g prime at -1. So we are going to see this one, 2 product. So this is the first function, this is second function. So we are going to do the first function derivative, then plus first function, we don't change, second function derivative. And the first function plus minus separate the terms. So we have 1, 2, 3, 4. We need to do each of them individually, use our product rule. Not product rule, the power rule. So this is our first rule. So an xn minus 1. So we use it many times. So the first one derivative, bring the 4 to the front. So 4 times 4, then degree minus 1. This one minus 3 times 3 to the front, then degree minus 1. Minus 2 times degree 1 minus 1 is 0. Then this one degree x to the exponent 0, so you times 0. This is our first function derivative. Then copy the second function here. Then don't forget, you need to continue plus. Copy the first function in the first bracket. Then do the derivative to the second function. 3 times bring the exponent to the front, first step, second step, degree minus 1. Then minus 6 times exponent to the front, then exponent minus 1. Constant, x to exponent 0, you bring the 0 to the front, is 0. Then simplify a little bit. 4 times 4, 16. All the other terms, variables same, but degree not same, they are not like terms, so we couldn't collect them. Then just, so 2 times 1 give you 2. Then copy 3x4 minus 6x squared minus 8. Then continue plus, copy the first term, first function in the bracket. Then simplify the second function is 12x cubed minus 12x. Okay, so this is g prime at x. Then now we want to find the g prime at x equals -1. We sub x equals -1 to g prime x. We have g prime -1 equals 16 -1 cubed. minus 9, negative 1 squared, minus 2, then 3, negative 1 to the exponent 4, minus 6, negative 1 to the exponent squared, minus 8, then continue plus 4 times the second, negative 1, 4 minus 3, negative 1 cubed, minus 2 times negative 1, minus 1, then times 12 times negative 1 cubed, minus 12 times negative 1. Then we are using a calculator to do the calculation. You will have equals this one negative 16, this one is minus 9 times 1, minus 2. Then 3 times negative 1 to the exponent 4 is positive 1, so it's 3. Then positive 1 times 6 is 6, minus 6, and minus 8, plus 4, positive 1 is 4. This one, negative 1, negative 3 is positive 3. Negative 2, negative 1, positive 2. Then negative 12, this one, plus 12. So the second term is 0. So this one is times 0, so this one is gone. This one 4, 3, 2, it doesn't matter, it's 8. 8 times 0, and this one negative 27 times this one is negative 11. Then you get your calculator out, you will find out it is negative becomes positive, so it's 297 plus 0 is 297. So this question is done. So for such question, how the mark will be given, the first derivative you get it correct, 1 mark, second derivative get correct, 1 mark, then you simplify them properly, another mark, then you sub in everything correctly, 1 mark, you do the final calculation correctly, it's 5 marks. So this is how the marks will be given on the evaluation. So this is example 2, and the last question is a little bit challenging question. So now our product rule is for 2 functions multiplication. Now I want you to find what happened to the 3 functions. Okay, if 3 functions multiply, what we are going to have. Okay, so this one, how we are able to find the 3 functions multiplication, we could introduce another function. So let's introduce another function m at x equals the last 2 multiply. Then we are able to write p at x equals f at x times m at x. Now we change the 3 functions multiplication to 2 functions multiplication. Then we know how to find the 2 functions derivative multiplications derivative, use the product rule. So f prime x times the second function and plus first function and times second function derivative. So, and after that, what we are going to do is we are going to find m prime of x. M prime of x, this is 2 functions. So we know how to find the derivative of 2 functions. So first function derivative times second function and plus first function and times second function derivative. So this is equation 1, this is equation 2. We are going to sub equation 2 into equation 1. Then you will find out, okay, we are going to replace this m prime x with this m prime x. And also we are going to sub this original one mx to here. Okay, so now we are going to see p prime of x equals g m f prime x. So p prime of x equals f prime of x. We could just keep the mx here first. Okay, then we just focus on m prime x using the equation 2 to sub in. So it's bracket h at x then plus g at x times h prime of x. And in the original question, we don't have mx, so we need to replace m at x with our definition for m at x. So we sub m at x equals g at x, h at x, sub in. This one I wrote here, it just represent, I'm going to sub in m at x here. So we are going to have f prime x, then g at x, h at x. Then we expand to get rid of the bracket. We call this simplification. Okay, simplification, the final answer need to have no brackets, no like terms. So we get rid of the bracket. So f at x times g prime x, then times h at x, then plus f at x, g at x, h prime x. Then from this question, what I want you to see is, did you see any pattern? So p prime x equals f g at h times, then the derivative is first function derivative times other functions, the second derivative times other functions, the last derivative times other functions. So 3 functions multiplication, you do 3 prime, but it's 3 terms, each one only one function derivative. And you could guess if p at x equals f g h l functions, then the prime you can guess is first derivative plus second derivative plus third derivative plus. And you will see that once we know how to use the product rule, you could solve any functions, any numbers of functions multiplication. It's just how many functions times how many brackets times. You just do 1 prime each time. 4 brackets and 4, 5 brackets and 5. It just continue. So this is the beauty of math. Once you know one thing, you could extend it to solve more complicated stuff. So this is what we have learned for today. And today is just a product rule. So it's just the f prime k at x equals f x times g at x, and the derivative of that one is first function derivative times other functions and plus first function times other functions derivative. And the homework is checking your understanding will be on delta math 2.3. So continue work on the delta math. Each question they have the example and video help. So, and also you have unlimited try. So I just assign 1 question for each type of questions, but you could continue. The bottom have keep practicing. You just click on keep practicing. You could, it will give you more questions. It's unlimited. Okay, the bottom have keep practicing. You could do 100 derivative questions. It will continue to give you more questions. They are different. Okay, thanks for watching.